Hello guys, so today I'm going to show you this quick tip of creating a wet map in Houdini from a simulation, and yeah, you can use it for a whole bunch of things. So this project is also on Gumroad. If you want to check it out, you can download it from there with other projects as well. Yeah, so let's go to the wet map setup. So over here we have a geometry. It has UVs, right? So I just keep the faces that I want to create the wet map on. And here we have the incoming simulation on this side, which is packed. So we just unpack it. These are our simulation points. So since our geometry has UV, as you can see over here. So what I want to do is to flatten our geometry in UV, right? But in our 3D, in our 3D view, I just need this geometry to be flat. So I can just easily do that with moved over here. If we check this, I'm just reading the UV attribute and then outputting that to points to the position. And if let me just turn off the light so you can see, so it's flat, but the problem is the geometry is still attached, so it's getting stretched. So I'm using this node split point split, enabling the normal attributes, and that's going to cut the geometry. If you look at the original one, this is all just one piece, it's connected, but the it will cut the geometry according to the UV layout. So this will the UV islands, I guess we call. So each piece will be separate from the other one, and that way, when we flatten it, we don't get this we don't get this nasty connection. Everything's just separate, a clean cut. The web map simulation itself is done in this SOP solver right here. If you look inside, just have this Vex code running. So let's just start from the particles that are coming in. So the particles, I've just converted them into a surface. If you look over here, so this an SDF, and with our geometry, collision geometry, I'm just scattering some points, a lot of points. And what I'm just doing is an attribute transfer in here, but I'm just checking this code. I think you can just read it. So I'm just checking if a point is within a certain distance of the SDF surface, its wetness attribute is going to be 1. But if it's outside, it's going to be 0. But over time, the points that are outside the SDF and have a wetness value greater than 0, that value will be going down for a couple percent in each frame, in each sub-steps you can stay. Yeah. And of course, to avoid stepping, the old simulation I did, as you can see, it had some stepping. So to avoid so stepping, I just had this a sub-step of 4, seems to work fine. And to make sure that works well, right here, I added this node, time warp, and just checked the interpolation between input frame is on. So I just check the interpolation is on. That way, when this is going through the sub-steps, the points also get interpolated between the frames. Yeah. And when I made this simulation, I turned off the receding. Yeah, so I have this going inside there, and then we get our point with that wetness attribute. As you can see over there. Now, from here, from our geometry, that's when I use this flat. That's when I use this flat geometry nodes, the flat geometry now. So from short geometry, I'm using this attribute interpret so I can transfer the position of these points that have the wetness attribute simulated on, right? I need to transfer them to a position that for the UV position. So this works because in the scatter node, I actually enabled these two attributes, prim number and prim UV coordinates. So this node is using those coordinates to check what position should they be at, by which on this surface over here, because it has the primitive number and of course the UV coordinates. So yeah, I can place these points in the position of this primitive right here. So I'm just scaling it up a little bit and then converting that attribute of ours, the wetness attribute, rasterizing it into a volume. And I'm just making sure that value is 1, because sometimes you might have the value be less or more. And over here, I'm activating the VDB, making sure it's a perfect square with this, for using this box over here. This is because what we're going to do over here in COPs, I want everything to be centered and fit in our image that's going to be outputted to fit perfectly with the UV coordinates of our geometry, like this, right? Everything is the exact position. So I'm just activating that, so making sure that it's a perfect square and then converting it into Houdini volumes. So since just one volume, the coordinates, as I believe, this is an old project, so I don't know if things have changed, how much, and this is not Copernicus, this is the old COP network, so maybe things have changed, but when I was making this project, in order for the COP network to read this volume, it has to be just to represent the color, RGB. So there have to be 3 different volumes, to each one representing the color. So just for this single volume, I'm just renaming one to from wetness to C.X. That's going to be color red, color blue, color green, XYZ. And then just merge them together. So we have these 3 volumes. That's because the Houdini volume doesn't really support having a vector volume in just a single volume to be a vector. Yeah, and in COPs, I'm just reading in that volume. If I can check the composite node over here. So I'm just reading in that Rust node and setting my resolution to 4K and setting the image plane to color, because that's all I want. You can set to different one with alpha colors and everything. I just need the color, RGB, and limiting to 16-bit. I don't really need it more. Yeah, and that's how we get this UV, and just render it out. And I use that texture on our materials. If I can check the materials for walls right here. So I have this wall texture right here, and I got this color code just to create that wetness effect. But I don't think I actually use this much. I just outputted that to a custom AOV, right? So from the render, you can check that's a custom AOV that's showing the wet map AOV. So I'm putting that so I can use it in compositing. While I'm compositing, that's when I will create the wetness effects on our live action plate. Yeah, so that's it. If you need to check out the whole project, is available on Gumroad, the whole simulation.